All right, so this is Chapter 4, Section 8, Complex Numbers. So instead of ignoring the fact that when I have a negative number underneath the square root, life just stops and we have to go to therapy, we are now dealing with it. Emotionally mature enough to deal with an imaginary number. So our learning objective is to identify, graph, and perform operations with complex numbers, and to find complex number solutions of quadratic equations. So our essential understanding is that complex numbers are based on a number whose square is -1. The imaginary, so we had real numbers, now we're adding a section called imaginary numbers. The imaginary unit I is the complex number whose square is -1. So highlight this. I squared equals -1. And I equals the square root of -1. So highlight these two things. Make sure, if you're taking notes on this at home, make sure you put a box around it and star, because we're going to use that property. Alright, so the key concept is, if I have the square root of a negative real number, for example, square root of -a, this is the math behind complex numbers, so roll with me. That's the same thing as -1 times a, and then if we have a times, we can give the square root to both the -1 and the a. So it goes square root of -1 times the square root of a. We just defined the square root of -1 as I, so that's the same as I times the square root of a. For example, if I have -5 underneath the square root, that's the same as I square root of 5. When you square a negative number in the square root, you get -5. So if I were to square -5, the square root of -5, I would get out -5 and not the regular 5. So just when you take the square root of a number that's a negative, you're going to get out the negative. Before we were taking this, we were squaring and getting a positive value. In this case, we're going to square and get a negative value. So we're going to do these, guys. How do you write each number using imaginary numbers? So the square root of -12. Well, for sure, I know I can say that this is I times the square root of 12. And we're going to do a little rational number review, because I know that there is a perfect square that lives inside of 12. It's 4. So 4 is a perfect square. So I'm going to go ahead and take the square root of 4 and put them out with I. So the square root of 4 is 2. And poor 3, he is not a perfect square. He stays inside the square root. So square root of -12 is 2i times square root of 3. Square root of -25 is the square root of -1, which is I, times the square root of 25, which is 5. We like to write the letters after the numbers, so I would definitely rewrite this as 5i. Square root of -7 is the square root of -1 times 7. The square root of -1 is I. And 4, 7, he is not a perfect square, so he just stays. All right, so we way back to chapter 1, we talked about natural numbers. We talked about whole numbers. We talked about rational numbers. We talked about real numbers. Now we're going to talk about imaginary numbers. So an imaginary number has the form a plus bi. And the reason we can say that all numbers are imaginary is because a is the real part. If your b is 0, so like 4, that number 4, the b part of the number 4 is 0, so you just have the real part of it. So you can write a complex number in the form a plus bi, where a and b are real numbers. If b is equal to 0, the number a plus bi is a real number. If a is equal to 0 and b is not, the number a plus bi is pure imaginary number. That means it doesn't have a real part to it. So we have real numbers, we have imaginary numbers, and we have pure imaginary numbers. So I'm sorry, my Venn diagram was askew. We modified it. So imaginary numbers and then pure imaginary. Oh, I'm going to keep it. Let's keep it. Haters going to hate. What haters? In the complex number plane, so you can graph complex numbers. We're going to let the a be on the x-axis and the b be on the y-axis. So the x-axis is going to be the real axis, and the imaginary axis is going to be where we would normally have our y's. So we can actually plot a complex number. We just go over a units, up b units. The absolute value of a complex number is the distance from the origin. So we got to make sure we highlight this little equation, because this is a quick and easy calculation that you're probably going to see on your assessments. Absolute value of a plus bi is equal to the square root of a squared plus b squared. So we're going to do the graph and absolute value of each of our numbers. So we're going to say that this is like 1i, 2i, 3i, 4i to 10i. Our a here is 5, and our b is -1. So we're going to go 5, -1. So, and I'm going to put an a right next to it so that I can identify that it's the one for a. And the absolute value of this guy is the square root of 5 squared plus -1 squared. That's the square root of 26. All right, so here we have our a is -3 and our b is -2. I'm going to switch colors so that we can see it a little bit better. It's going to be red. So we have -3, -2, and that's b. And then the absolute value of that guy is the square root of -3 squared plus -2 squared. -3 squared is 9, plus -2 squared is 4. 9 plus 4 is root 13. Are you able to plug that into your calculator to find the approximate value? I would hope so. If you cannot, please let me know right away. I'm happy to help you with that. All right, so let's do it green. So for 1 plus 4i, my a is 1 and my b is 4. So it goes over 1 up 4. That's c. And then the absolute value of that is 1 squared plus 4 squared. 1 squared is 1, 4 squared is 16, 1 plus 16 is 17. So I have the square root of 17. All right, so now we're going to do some number manipulations with I. And just to let you know, when you are adding or subtracting I, it's like combining like terms with our x's. We treat it just like an x. The only difference is at the very end, if you have a squared, then I squared, guys, from your notes, I squared is equal to, what does it say in your notes? So I squared is equal to -1. So you treat I just like you would a variable. It rolls around and you simplify it just like a variable, except at the end you replace I squared with -1. I'm going to put that up there so that we can remember that. So here I'm going to combine my numbers together. 7 plus -3 is 4. -2i plus 1i gives me -1i. Same thing here. I have a negative outside these parentheses, so I'm going to distribute it. So that gives me -3 and plus 2i. And then I'm going to combine my like terms, my i's with my i's, my numbers with my numbers. So I got 1 minus 3 is -2. And I have 5i plus 2i, which is 7i. Here I have the same scenario. I got 8 plus 6i, and I'm going to distribute the negative. So I have 8 minus 8 is 0, and 6 plus 6i is 12i. So my answer for C is just 12i. All right, last one. -3 plus 3 is 0, and 9i plus 9i is 18i. That's just equal to 18i. If you have a 0, do not include the 0, especially for those of you guys who do online assessments. When you type it in, if you put the 0 in there, it might mark it incorrect because it's not in simplest form. Now we get to the part where we're multiplying it together, and we're going to once again treat the I like an X. If we multiply it and get an I squared, then at the end we'll substitute in -1 for that. So the numbers get multiplied together. 7 times 3 is 21, and the i's get multiplied together. I times I is I squared. Now here's where we replace the I squared with the -1. And -1 times 21 is -21. Okay? So let's look at these other two questions. If I FOIL these guys out and go 2 times 4 is 8. First inside. -3i times 4 is -12i. So we're just treating the I right now like it was an X. First inside, outside. 2 times 5i is 10i. And then -3i times positive 5i is -15i squared. So I'm going to go ahead and combine my like terms, and then I'm going to deal with the I squared. So I got 8 right now doesn't have a buddy to combine with. Minus 12i plus 10i's is -2i's. And then -15, I'm going to replace the I squared with a -1. And then simplify. -15 times -1 is +15. And now I can combine the 15 and the 8 to get 23. So I get 23 minus 2i. Let's try that one more time with negative 4 plus 5i times negative 4 minus 5i and see what happens. Negative 4 times negative 4 is positive 16. 5i times negative 4 is negative 20i. Negative 4 times negative 5i is positive 20i. And negative 4 times negative 5i is positive 20i squared. So I times, hold on. Sorry, back up the track. There's a 16. Oh, sorry. I did the same one twice. I need negative 5i. This is the amendment. Sorry, 5i times negative 5i is negative 25i squared. Okay, I was almost trying. Now we're off this way. Okay, so we got 16. Negative 20i plus 20i gives us 0. And we have negative 25i squared. We're going to replace the I squared with the negative 1. And then negative 25 times negative 1 is positive 25. 16 plus 25, 41. So the answer is 41, and voila, the I, since we replaced the I squared with a negative 1, the I's disappeared. All right, so that last problem brings us to the topic of complex conjugates. So in a complex conjugates, our A values, the real parts are the same, and the complex parts are opposite. So A plus BI and A minus BI are complex conjugates. So if you notice, the sign on the A doesn't change, but the signs on the B need to be the opposite. So what we're going to do is, in math, they do not like I's in the denominator. So in instances like A, B, and C, when we see I's in the denominator, we're going to multiply the top and the bottom by the complex conjugate to get a whole number denominator. So for example, I have 5 minus 2i over 3 plus 4i. We need to, it's called rationalizing the denominator. We need to rationalize the denominator, so we're going to multiply the top and the bottom by the conjugate. So if the bottom is 3 plus 4i, the conjugate is 3 minus 4i. And I know it kind of looks like a 42, but it is a 4i. So I'm going to FOIL out the top, simplify it down, and FOIL out the bottom and simplify it down. So we're going to take a look at 5 times 3 is 15. 5 times negative 4i is negative 20i. Negative 2i times 3 is negative 6i. And negative 2i times negative 4i is positive 8i squared. So that's the top. The bottom FOILs out. 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. And 4i times negative 4i is negative 16i squared. Okay, so all I did was I found the conjugate, multiply the top and the bottom by it. So next step is going to be to simplify. So I'm going to combine to get, my 15 right now doesn't have a number that it's going to combine with. Negative 20i minus 6i is negative 26i. And I'm going to replace the I squared with a negative 1. Then I'm going to deal with the denominator. So right now 9 doesn't have anybody to combine with, so we're just going to rewrite them. Negative 12i plus 12i is 0, so they combine to equal 0. And I'm going to replace the I squared with negative 1. All right, let's take this thing home. 8 times negative 1 is negative 8. 15 minus 8 is 7. 26i stays because he doesn't have any other i's to combine with. Negative 16 times negative 1 is positive 16. 9 plus 16 is 25. So as you can see, multiplying by the conjugate gives me a whole real number denominator, and it gets rid of the I. All right, so we're looking at 6i right here. If I rewrote this as 0 plus 6i, we can then match it up with the A and the B from our conjugate form. So its complex conjugate is going to be 0 minus 6i, or just negative 6i. So we're going to multiply the top and the bottom by negative 6i, and I do it to the top as well as the bottom because that keeps it equal. So 4 minus I, I'm going to distribute out the negative 6i, so it's negative 24i. Negative and negative give me a plus 6i squared. And then 6i times negative 6i gives me negative 36i squared. Go ahead and simplify that. Hopefully your guys' writing is smaller than mine. I'm going to replace the I squared with a negative 1. And I'm going to do the same thing on the bottom. And then we're going to go ahead and simplify it. So 6 times negative 1 is negative 6 minus 24i. We like to have our real component in the front. So whenever you're inputting answers, make sure your real component is in the front. 36 times, so negative 36 times negative 1 is 36. I can simplify this down even further because I know 6 goes into each one of these. It's as if, well, you can start out with 2, 2 goes into each of them, and also 3, 3 goes into each of them. So I can reduce everything down by a factor of 6. So negative 6 divided by 6 is negative 1. 24 divided by 6 is 4. And 36 divided by 6 is 6. And that is our final simplified answer. All right, I know it got lost in here. We're just gonna, let's see if this is a summary page now. I won't show you the third one. We'll get on to the next one. Okay, so we're gonna look at the whole reason we look at complex numbers in the first place. It's so that we can factor stuff and find solutions. So we're going to look at the factored form and then use that to solve the equation, finding the imaginary solutions as well. So what can I factor out of 5x squared and 20? What do they have in common? Kylie's right, it is 5. So I get x squared plus 4. So we're going to need a property that I cannot write down. So you guys add this property to your notes. We have a plus bi times a minus bi, or the product of your complex conjugates. It's going to equal a squared plus b squared. So when you multiply two conjugates together, you get just the a term plus just the b term squared. So we're looking here. I factor it out, and then I have this guy here. This is a squared plus b squared. I got a 5 out in front of it. So a is equal to x, and b is equal to 2. In that scenario, I can say that this is 5 parentheses a plus bi times a minus bi. Okay, let's see how it applies to x squared plus 81. We know x squared is equal to x squared is equal to a squared, so in this scenario, a is equal to x, and 81 is equal to b squared, so b is equal to 9. So I'm going to put that together using this equation. We have a, which in this case is x, plus b is 9, I times x minus 9i. Factor. All right, so now let's bring it home to the purpose we do this. When we are solving quadratic equations, sometimes we might run into a scenario where we need, where we have complex roots. So if I have, say I have a smiley face parabola and it doesn't cross the x-axis anywhere, then we have complex roots. So I'm gonna show you guys this with A. I'm not going to do B. It's I think it's sufficient with just one. So if you take the quadratic formula, x equals negative b plus or minus b squared minus 4ac divided by 2a. First thing we do is identify a, b, and c, and then plug them into our equation. Negative b is negative 1, plus or minus b squared. Make sure you, when you have a negative b, make sure you put him in parentheses, times 4ac. All divided by 2 times a. Simplify, simplify, simplify. X equals 1 plus or minus square root. 1 squared is 1. Minus 4 times 3 is 12 times 2 is negative 24. So 1 minus 24 is negative 23, all divided by 6. We now know we're going to deal with that negative number under the root. It's going to be equal to negative 23, positive. It's going to be equal to 23i. Remember, we take that negative 1 and we make it the I. 23 is not a perfect square, so he stays. So our two answers are 1 plus I root 23 over 6. And 1 minus I root 23 over 6. So now when we use quadratic equations, we actually deal with a negative underneath the square root. And that's everything you need to know about complex conjugates.